Alright, so the next lesson we have are conditionals. Now, if you remember in the last video, I briefly covered conditional. I didn't really want to, considering that wasn't where we were at yet, but I briefly covered the if statement. So, when we look at an if statement, now this is a statement, like the term I use statement, the thing that has brackets, you put something in brackets and it'll run that code. An if statement is similar to a function, except it's not at all a function. The similarity it has is the fact that it will run code within the brackets. The difference is it only runs that code if a certain condition is true. In this case, we of course have two numbers. Now this is kind of hard to look at, but another way we can think of it is if we put this both in parentheses. Of course, we understand integers, but this Boolean variable t is the set equal to the Boolean a equal to 4. In this case, this means this will check to see if this number and this number are equal. If it is, it will return true. Since a is in fact 4, it'll become true, meaning that this will run this. And of course, this is the exact same as t, so it'll of course run as well. Now we're going to talk about more operators that I have in comments over here, this bit. So this is just declaring the Boolean variable result, and basically this has different operators. We're using, of course, A and B, which A is 4, B is 5. And we're using these operators to find out if it's true or false. Now, if you remember in elementary school math, we did uh, we did operators such as greater than or less than. If this number is greater than this, or is this number greater than this? So basically, is the number less than or is the number greater? And we also had greater than or equal to, less than or equal to, but since we can't put a line underneath the sign, we use an equal sign beside it, to the right. In Java, the equal sign will be to the right of the operator. So basically, this is checking to see if A is less than B, which it is, it'll be true. This checks to see if A is greater than B, which it is not, so it is false. And over here, I'm just going to have this out for reference, but A equals 4. Forgot it does that. Okay, you can ignore that. And then B equal to 5. Just, just to have a memory of it. And then this checks to see if A is less than or equal to 4, if it is less than or is equal to, and it is, so true. And this checks to see if B is greater than or equal to 6, which it is not, so it's false. This checks to see, of course, we talked about this, equal. If A is equal to B, which it is not, 4 does not equal 5, so it returns false. Now this, I mentioned it once before, but this is the not operator. It will return the opposite. This is basically saying A is not equal to B. And as we know here, A is equal to B, which returns false. So the opposite of that is going to be not equal to B, so it will be true. If equal to is false, then not equal to will be true. And the same works vice versa. If equal to is equal to B, if A is equal to B is true, then not equal to B would be false. And of course, you can actually put the not operator in front of any condition. So it could be not A. And that checks to see is not A. Oh wait, no, that's a number. That actually doesn't work if A is a number. But you could do something like putting it all together in parentheses, putting a not in front of it, and this will basically say A is not equal to B, which is true, but reverse it again, now it is false. So basically this is the same thing as this, just more complicated. Alright, and then now this is the or and the and operator. It shows down here the not operator that I just described. But the or operator checks to see if just one of these conditions is true. If just one of them is true, then it will return true. This will become true. And that means if one's true, one's false, it'll be true. But if both are false, it'll be false. Over here, this says this is the AND operator. Now AND is basically the opposite of OR. AND checks to see if just one of these are false. If just one of them is false, then this will be false. So unless all of them are true, then it will not be true. It'll be false. All right, so that's all of the operators for booleans. And now we're going to come back up here. We discussed this, so I'm going to start off here. We have examples of if, oh, also, one thing I did not mention is the reason why we have brackets and semicolons. I discussed it briefly, but the reason is because Java doesn't use space to separate things. Things like Python use indentions in order to separate the code. Java doesn't. In fact, the only thing it uses is brackets and semicolons, and of course parentheses. So basically, if I wanted to, you could just remove all space, and you could do something like just removing all space. You just don't have to have space. I'm just going to do this, run it to show you that it works, and yeah. So of course, this is all a few lines of code put on the one. It will work. See, works. The only reason why we don't do that is because it's hard to read. We include these spaces in order to make it more readable. It becomes much easier to understand. So statements, brackets, code, semicolon. This, of course, symbolizes it's a conditional statement. And yeah, if statement just does that. All right, so now we're going to go back down here. If A is equal to B, this just checks the A is equal to B, which they are, then it would run code, which we already discussed. This is an if-else statement. This basically checks if A is equal to B, then of course you run that code. But what happens if it's not? If it's not, these just don't run. Ifs don't run. But what the else does is it basically sends it here. If this is not true, then it will run whatever's here. Whatever's in this bracket. Else is just the last resort. Now, else if, now I'm also just going to add this real quick. Okay. So basically, this checks to see if A is equal to B, run this. Else, if, okay, so this is basically the same thing. There would be no reason for it to ever get to else here, but I used it for a specific example I'm about to give. But else if A is not equal to B, so basically if A is equal to B, else if it's not equal to B, then it would run code. And now if for some reason, whatever you had an else if and if were not true, it would run else, just else. But we technically don't need it because else if does the opposite. All right, so now over here, if A is equal to B, on another line, while, else, double rainbow. Now when we get over here, we have result. Okay, so this, I believe, is another form. This is another form of if statement. If you're taking APCSA, you don't ever really have to do this. I never did. I don't think the teacher ever did either. This is like a very convoluted if statement. I think this probably should be a boolean, not an int. I think they did an int, but pretty sure that's supposed to be type mismatch now. Guess it isn't it. I don't know. This is just. Oh wait, no. Oh, okay. I get it now. I get it now. This it isn't it, but it is still an if statement. This is a complicated line of code right here. So this is basically the exact same thing as this. It says if A is equal to 4, then of course it will be true. And result 2, it checks if A is equal to 4, then result 2 will then become 1. Else, that's what this line does, else it makes result 2 8. If you ever get confused at this, you can always just look back at this. But this is just a simple else if statement done in one line of code. I'm just going to go back over it again because it confuses me too. But if A is equal to 4, then send 1 into result 2. Else, that's what this colon does, else, send 8 into result 2. Which of course is what this does. And now when we look down here, string A2 equals new string wow, string B2 equals new string wow. Okay, so this is where some things start to get confusing. This is comparing strings. Because, comparing numbers is relatively simple. We use certain operators for that. But strings are a bit different. So, when we check to see if two strings are equal using the same method as numbers, what it does is it checks to see if it is the same object. Since strings are objects and not primitives, it checks to see if they are the exact same object. And I mean the exact same object. So, there are two different objects, while this one basically creates a new string under the object A2. That's why when you do A2 equals same A, it's true. While when you do A2 equals B2, that is false. Of course, the smart thing to do if you're actually checking if the string is equal, so you just use the dot equals method. Variable name dot equals method, and in the parentheses put the other string variable name. Alright, so that covers all of the conditionals file. And I'm gonna give you roughly 5 seconds to go do the practice for it, and then we'll start. I'll review the practice. I'll review the practice. So, alright. Alright, so here we go. So the prompt says, change the variables in the first section so that each if statement resolves as true. And of course, as string A, new string wow, string B wow, C A, D C. Boolean 1 equals A equals B, true. These two are false. And then if all three, this checks to see if any of these are false, and if it is, then it will be false. Right now the output is nothing. So when we go over here, in order to make, so right, A equals B is true. These two. Okay, so, and then in order to that, D dot equals B plus exclamation mark. Of course, that is not true, because D equals C, which equals A. And then B3 equals C dot equals method of A. So C equals A, therefore not is going to return false. In my computer, there we go. So when we look at what they did, they kept A stays the same. B equals A in order to B equals A in order to keep this part true while making this part true. Because D now equals C, which C now equals B plus exclamation mark. That made sure that they changed C in order for it to no longer be equal to A. So B plus exclamation mark. So that way, A equals B. This does in fact true. D equals C, which equals B plus exclamation mark, which is true. And because they changed C, C no longer equals A, which makes this fact true, which then proves out to be success. Alright, we're actually going to come back over here to the if, because I forgot to run it for you guys. So over here it's so true, oh it's a 4, and then just double rainbow. If A equals B, another line, wow, and then double rainbow. Something ever happened to A? A does not equal B, that's why. Double rainbow. And then it print off 1 over here. Result 2 equals 1 because A equals 4. Alright, so that covers the end of this lesson. Alright, so this lesson may be a bit shorter because we're talking about arrays. Now, much how like a string is a collection of characters, an array is a collection of a data type. It could be strings, or it could be any data type. You can even make well actually no, I'm not gonna get into that yet. But well you can make objects. You can make objects in array. You can make any primitive data type in array. They're just a collection of data. And the way we initialize it is we either do int two braces braces maybe. That's what I don't. I'm gonna refer to these as braces because I don't remember the exact terminology. Sorry guys, but two braces, uh, and then the variable name, much like you would just do int array. Another way you can do it. There are many ways to do this, by the way. You can do uh, you can set the size by doing array equals new int, and then setting the size of 10. Now another thing with Java is the array, whenever you want to refer to an array, you always have to start off on 0. So when you set up a size of 10, it's gonna put elements in places of 0 through 9. So basically this, when you first initialize it, it's just gonna be blank, 9 blank spaces. Maybe even 9 blank zeros. So when we set here, we're basically setting the first element of the array to 4. And then this one is the second element of the array is setting equal to the first element plus 5. So of course this is 9 elements long, and that's you basically putting data into the arrays. Now you can also do this with loops, which is shown right here. Luckily though, the next lesson we cover is on loops, so that's the bright side. So when we look over here, we have array 2, and this is basically combining both of these. Int array 2 equals new int 5. And then this is accessing the first element by putting 4 in place of the first element. And now another way you can do it, you can just assign the values as you please. As this is int array 3, instead of saying new int, and then 1, 2, 3, 4, instead of saying new int 4, what this does is just goes ahead and sets it numbers 1 through 5. And then of course you can print now I added this statement, I think. You cannot print out an array. Since an array is like an object, it's not really like an object, but basically it's not going to work. It's going to print out its object value, and therefore is not going to print out what you actually want it to. So in order to print it out, you have to print out each element at a time using a loop. You don't have to worry about what this stuff means. This is the stuff used to print off an array. There's more than one way you can set this up, but this is just one of the methods of printing off an array using a loop, and we're going to get into loops next lesson. So when I run it, this is the basically like the object ID of the array, and that's what's going to print out when you print out an array. So when you use a loop, you just basically loop through all of the elements, printing off each one of those elements. And of course, in these elements, once you initialize it as an int, you can only put ints in here. You can't put strings, you can't put doubles, you can't put any of that. It will return an error. All right, so next, I'm going to give you about 5 seconds to go do the activity, and then I'm going to discuss the activity. All right, so the prompt is change the values in numbers so it will not raise an error. That's all we got to do. So the numbers it gives us is int 1, 2, 3 sets a new integer array 1, 2, 3 sets the length numbers to 3, which this does not work. So these, even though there are 3 values, of course the first element starts off on 0, so it's going to end on 2. 0 through 2. So when you go 3, it's going to give you an index out of bound error because you're trying to reach outside of the array. So of course we change that to 2. Going over here, we have a character array, chars equals new character length. So it'll return, so basically it'll give it a length of 3. Character array will become 3. And then when we come over here, characters numbers.length plus 4 equals y. So this, I'm pretty sure you could already tell this is not going to work because this is saying numbers, oh, by the way, dot length, basically, when you use the dot length added onto an array, what it'll do is it'll return the length of that array. So of course here, now this doesn't take into account for 0, by the way. That's why over here we change it to -1. But numbers.length, so when we look at numbers, this of course is in fact 3. So this will be 3, which of course this itself, length, is only 3. They're the exact same size, numbers. Numbers and cars are the exact same size. So that's 3. So this is going to say numbers.length. So this is basically saying cars at element number 7 equal y. Now since there's only 0 through 2, 7 of course is way out of bounds and it's going to return an error. The way you fix it is you do 3. This will equal 3 because it's numbers, length, 3. And then you subtract it by 1 to get to element 2 equal to y. That's the last element in the array. That's technically number 3, but its element listed as number 2 since it always starts on 0, not 1. Then you just print off done because it did not raise an error. There we go. All right, so that's all of arrays. Arrays was pretty short. All right, so now we get to take a look at loops. There we go. Now we get to take a bit of a look at loops. Loops just run certain lines of code certain amount of times until, of course, they can no longer be ran. And, well, until whatever condition says that it needs to stop, stops. So the first loop we actually have is a for loop, and I've also included brackets on the side just so you know anything that goes in here is going to be ran. Now, to dissect this for loop, there are 3 parts to it. The first one is a variable declaration. You can initialize the variable in the first spot, and that's to be used, is pretty useful because you can use it to do what we do here is we set I equal to 0, but then we have our next part, which is the condition. The middle part basically says once this condition is false, this loop will no longer be ran. And then the last one is an increment. An increment is a math term, and basically it's you can add a number by a certain number and it'll be added every time the loop is ran. That can help stop the loop. In this case we have I++, but if we ever wanted to, we could do I plus 2. Now it'd probably have to be plus equal to. Yes. Yes, it does. No. Okay. So don't include a semicolon at the end of that one. But basically, what plus plus does is it adds whatever variable, whatever integer you want to add by 1. Plus equals is the same thing. I'm just going to go down here, say it in the comment. But I plus equal to is the same as I equals I plus 2. I equals I plus 2. So we're just going to put that in parentheses, get a better look. These are the exact same. So really, you can do any of those. That's how you add. Plus equals just adds by that number times plus 2. And you can also do times equal to, divide equal to. We'll get more into math later, but for now, you at least know what an increment is. And we're just going to go back to plus plus. So that's just a blank variable. We would put our code in these brackets, which of course is what we had this for. Another way of writing the code. And this is basically saying the int I0, int I equals 0 when the I is less than 3. It's basically the exact same condition as the one above. And it'll be ran a total of three times because it'll be added up until to equal 3. So it'll go 0, and then once it finishes running, I will equal 1. Then it'll run again, I will equal 2. This will run again. Now that it knows, after it runs again from 2, I is going to equal 3, and that's where the condition says, oh, no, stop, no more running, because that condition is now false, no longer true. That's the basics of a for loop. This print line is just here to separate this print and the next one. So, looking over here, we have the while loop. So here we have int k equals 5. A while loop is an if statement that just runs until it is no longer true. So in this case, k is equal to 5. While k is less than 5, run. Of course, it won't run because k is 5, and it's not a less than or equal to. So basically, it'll just run until it's basically an if statement that'll just run until this is false. Very similar to a for loop, but it's just the center condition. Now we have a do while. Do while is set up a bit different. It's do, parentheses where you put in the code, and then after that you put while, and then you put the condition. So basically this is saying the code will at least run once, and then it'll check the condition to see if it's true or false. So in this case, the code will run. So I'm just gonna print line done. So basically what this does is even though k is less than 5, it will be ran once. Now that it knows that k is not less than 5, it'll stop this loop. But that's basically how a do while loop looks. Make sure the while comes after the brackets. That is important for syntax. And now this is a limited for loop. It acts just like a while loop. You can omit any of the other conditions of the for loop, whether it be the variable declaration or the increment itself. You just have to put semicolons in either left or right. But in order for a for loop to work, you do have to have a condition. So that's the bare minimum. So if you wanted to, you could have int I equals 0, and then just remove the last part, which is the increment. That just works exactly like a while loop. Now this next for loop is called a for each loop. A for each loop's purpose is to run through an array, to loop through until the array is been ran through entirely. It just goes through the entire array and stops when there's no more elements left in the array. In this case, we have a size 4 array, element 0 through 3. So what you have to do is you have to create a new variable name, and then colon, the array name. So you'll be using this variable name to reference each element in the array. So when we start off here, L will first start off in the loop, equaling 2. Once it runs, L will then become 0. It'll run again, it'll become 1. Then it'll run for its final time, become 3. Since there are no more elements, it'll stop running. And it's the exact same. Another way you could, of course, do a loop, run through an array, is using this. A for each loop just looks a whole lot better, cleaner, and it's just a lot better in general. So we have here, of course, our declaration I equals 0. I is less than array.length, so if it ever gets up to the length of the array, then it'll stop, which is what we want since the elements start at 0, not 1, while length starts at 1. And of course, I++ to increment 1 each time. So basically, this and this are the same thing. Once again, this just goes, this is what, I'm going to explain this again. But, so, array. This is the array we want to reference. This variable has to be the same data type as the array. And you use that to reference each element of this array. I wasn't sure if I made that clear enough, so you just use this to reference it. L becomes 2, then it becomes 0, then 1, then 3. Without actually having to say array of I, that's basically what L is. L is array of I. Okay. Now over here, explain why I initialized I before the loop. I remember there was a reason for this. Yes, okay. So int I, the reason this is declared before the loop instead of during the loop is because if I want to reference I outside of the loop, I have to make it a variable before the loop. If I say int I equals 0 instead of doing this, basically you cannot access I outside of this loop. You can only access it while you're inside this statement. Once you're inside this statement, that's when you can reference I. But if you say int I over here and then you just change the value of I inside the for loop, you can then access it all the way over here instead of just only exclusively inside this loop. And of course, this is an I of 0, I less than 5, I++, goes for about 5 times. If I becomes, this is what is called a break. Break basically says if I is greater than or equal to 2, break. So if I ever, so I 0, 1, so it'll only run about twice. Once it becomes 2, the break command is initiated, and the for loop will stop. Break is another way of telling the loop, hey, stop here, no more, we don't need this loop anymore. Outside of the condition. That's the second way you can end a loop, is just using the break command. So you either have I less than 5, or if this condition is true, it will just break the loop. And then over here we have if I is less than 1, continue. Oh, right. Gotcha. So I'm gonna first run it as is. So of course we have over here, we have done 1, 0, 1, 2. That's the beginning one. The console go. There it is. So 0, 1, 2. And then over here, done. We see that do while worked, even though the condition was in fact false. And then over here, prints off the array twice, 2, 0, 1, 3, 2, 0, 1, 3. And then over here we have yoo-hoo, and I is 2. But when we initialize the continue command, continue is similar to break, but what it does is, because it print, so the for loop actually ended here, that's why I printed off yoo-hoo twice. But the continue, what it'll do is it'll stop the current iteration and move to the next one. Aha, so that's what it means. So continue will just basically, it'll just stop everything else. So if you wanted to have this like earlier on, it'll stop everything and then just go to the next iteration of the loop. So if I had over here system dot, well, I guess it's already doing it. But okay, so another way you can tell. So how it ran yoo-hoo twice, but only ta-ta once. Once you hit continue, it'll skip over ta-ta and just go to the next iteration. That's why it does yoo-hoo, but no longer ta-ta. That's That's pretty much all of this file. So now we must go to the questions. I'm gonna give you 5 seconds to do the activity practice, and then we're gonna go over the answer, and I'm gonna explain it. Alright, so the prompt is to loop through and print out all even numbers, each in a separate line, from the numbers list in the same order they are received. Don't print any numbers that come after 237 in the sequence. So it wants us to print off all even numbers, each in a separate line, so we will use print line, which is what they did. Don't print any numbers after 237. So that's why over here, if, so what it does is int L equals numbers of I, uses L to represent each element in the array. If it equals 237, break so it doesn't go past 237. Next, of course, the last thing we have is to loop and print out all even numbers. That's where we use the modulus. Modulus is a math term. Basically, it returns the remainder of a number. It divides it and returns the remainder. So basically, another way you can think of modulus is if you were to divide something like 6 divided by 5. 6 goes into 5 one time, and then you have one number left over. You subtract how much you have left over from, well, I guess you don't subtract. Basically, to think another way, I'm just going to use this. So basically 6 minus 5, that equals 1. So that means 5 goes into 6 one time, so 5 times 1. So 6 minus 5 times 1, that equals 1. That does not equal 5. Not equal 5. 1 does not equal 5. So basically, 1 is the remainder, and that would also mean that it'd be 1 remainder of 1. So 1, 1R1. So it's 5 goes into 6 one time with the remainder of 1. Modulus would return only the remainder, while division would return everything but the remainder. So modulus just goes up to there, and then division. So they use modulus in order to divide it by 2. If there is 0 remainder, then it is an even number. If there is a 1 remainder, then it is an odd number. That's how it gets each even number to display. Uses print line to do every line. And so when we run it, every even number up until 237 is printed. That's all of this lesson. If you enjoyed, please like and subscribe.